y'all and I'll go ahead and start. It's barely viewable. I don't know. But I can zoom in on it, so I'll do that as I go along. Luckily, next semester, I'll be in a room where I can actually do this more efficiently. Okay. That is great. That is a good idea because I completely forgot that twice in dynamics. And I was like, okay. God. Okay, let me make sure we're okay. All right, so at least I'm there. Okay. All right. Log in. That is me. That is me. Please don't make me do that. Okay, good. Okay, and this happens to be statics, which for some reason is at the bottom of my list, and that I don't know why, and for some reason it keeps coming up that way. Okay. All right. Pecan, I don't know about that. Oh wait, you gotta hit the submit instead of just hit enter. So I had a whole series of problems. The question is, where did I put them? I may have actually, okay, Monday, work Monday. Okay, wait a minute. Where did they go? Ah, there's one of them. Here's the other. That, so it looks like that's where I start. Looks like that is the last one I did. This one. So what I'm going to do, I am going to go down this path of doing the highly efficient way of doing it. And that's kind of this. Okay. So we already recognized from last time this structure. In other words, that this is the unit vector for one, unit vector for another, and a unit vector for the third one. And if I line them up so that they're X, Y, Z, the matrix gets put together really, really, really quick. So most people don't teach the class kind of like this, but I try to find things as quick as I can to get to the answer. And the thing is that also, if you do that, often you make a few less mistakes. So, you know, obviously he's going to want, you know, something here as far as a weight or something. So I'm going to kind of ignore that for the minute and just focus on finding my unit vectors. Okay, so I'm going to use this one as a unit AC. This one is really easy. This one is super easy too. Unit AB. This one's super easy. Unit A. I'll call that P for pot. How about that? Unit AP. And then one that runs up here. Unit AD. The thing about this one, this is the only one that's difficult at all. So the first two I can list I'm sorry, the first three that I did, I can list like in a matter of seconds. I know this one goes straight out there. So it's just simply I. Then the unit, is it, yeah, it's visible. Unit AB heads straight out the Y here. Now, unit AP, it's a minus K. It's going down in the Z. Since those are so easy to find, I'm going to kind of move them to the side and then work on the other one, which is the unit AD. So what I'm going to do first is find a vector that goes from A to D, and I'm going to use my little funny way of doing things. I'm going to run down the X first. Okay, I'm going to back it up. I'm going to run down the X, then I'm going to run down the Y, and then I'm going to run down the Z. So if I run down the X, the vector there goes minus 1.5 I to get me to that point. And this vector goes into minus 2 meters J, and this vector goes up 1.5 K. So, yes, I did. Yeah, I was going to say. If I want to just put this in here, RAD equals 2. I'll go ahead and grab out the 1.5. Then I'll grab out the 2. Then I'll grab out the 1.5 again. And hopefully I listed those correct. Minus 1.5, minus 2. Oh, and an extra comma there. Is that even visible? That's all not even visible. I can't. Tell you what, we'll do this. While I'm doing that, is that even visible? So there's that vector. You know what's funny is I don't particularly mind. This sounds stupid, but as you're sitting in here, if you want to draw the stream up yourself so you can watch it, and you can cut the volume down, you'll be about 10 seconds behind the screen because the screen is so awful. Like I said, next semester they install something for me, so I'll be able to make this high resolution. So I haven't got it to work yet. If you can tell, this is kind of, you can see that, but it's not that great. Okay. So now that I got that, I want to find the unit vector that way, RAD, and I'll zoom back out in a second. Unit AD? AD is equal to RAD divided by the norm of RAD, not RAD. And now, I'll sort of shrink out to about right there. So what I'll get, okay, I'm going to bounce back and forth here. Minus 0.51450I minus 0.68599J, and then plus 0.51450K. Now I'm going to do something weird. Okay, now I've already introduced you to the way of kind of listing the vectors in the rows. So what I'm going to do is I'm going to construct something really strange here. Okay, so what I'm going to do is the x equation will go first. The y equation will go second, and the z equation will go third. The next thing is, you know what, let me get this part off here. The next thing is, everywhere, okay, so my subscripts are going to match. In other words, my tension in AD is going to be a scalar value of the tension in AD times the U AD. So in other words, I'm going to make this so that all of these subscripts match. So obviously this is the vector, unit vector pointing towards D, but there's going to be a tension in that direction. So that's going to be a tension vector, UAD, A and D. Now, if that's the case, and I do it this way, this and this always go together. So just like this, okay, tension AB is going to be the value of the tension in cable AB times the unit vector AB. So again, all these match each other. So what I'm going to do, I'm going to do something kind of weird here. I'm going to go in and I'm going to list them. I don't know which one to list first, so I'll do TAB, TAC, AD, and then I'm going to do one more, TAP. Now, if I'm doing it this way, I'm going to kind of let you think about this for a minute. Then the vector that I'm multiplying is TAB, TAC, TAD, and TAP. Now there's three equations. I've listed it as if there are four unknowns, but in fact there's not, because you do know this one. But I'm listing this in a way that is generic and covers all bases. So when I list this, I'll end up with three equations. The one in the x, 0, 0, and 0. Why am I listing this? I'll show you in a second. After I put these numbers in, I'll show you what this represents down here. So first, let me go get each of these. Yeah, that one goes there. So it looks like that. Again, I'm listing the vector vertically. Okay, so here's what I mean. I have no I component here. I have, for the y component, which would be j, I have 1. For the z component, I have no k there. Now, if I list TAC, it would be associated with UAC, because I think I wrote that. No, I didn't write that one, but it has a 1, a 0, and a 0. In other words, it has an I. The I shows up here. It's in the X. There is no J, and there is no K in that base vector. TAD. Now that's the one with lots of numbers. So I'm going to try my best to just, I'm going to have to copy this number, then that number, and then that number. Minus 0.51450 minus 0.6, that's not a 6, that's a 6, 8,599, and I know there are other digits, but for the time being, that's good enough. 51450. Now, you got TAP. Now that one, actually you know, but let's pretend we don't know it yet, and just list this vector in there. It'd be 0, 0, and a -1. Why -1? because it points down and that's up. Now, if you look at each one of these, believe it or not, you got 3 equations here. And you know how to, I hope you know how to multiply this out. So if you want to know the first equation, you know, you take this number, that times that, and list it. So 0 TAB. Then you take this number times that number and list it, plus TAC. You take this number times that one, and you list it. 51450. I think I copied that right. TAD. And then you take this one times that one and list it. I'm putting all of them. TAD. And then on the right hand side you grab that one. So what is this equation? This is simply sum of the forces in the x equals 0. There's your 0. Here's your sum of the forces in the x. Let's go and make sure this makes sense. Does TAB have a component in the x direction? Now remember, this is the x direction out this way. So as I move, here's your x. And I'm going to be zooming in. So you realize there is a TAC component. It sits right there. There is no TAB component. This doesn't go in the x, nor does that one. And so what you end up with is only this one offsetting a component of that tension going in the opposite direction. And that's what you see out of this. You see that the only 2 terms that are not 0 is this one and that one. So you can get a relationship between TAD and TAC. Now, you do this over and over, and you'll end up with something. You'll end up with the sum of the forces in the y direction out of the second row, and you'll end up with sum of the forces in the z direction equals 0 out of the third row. How, if you'd have to say, you've had matrices before, does this, and how does this sit with you? Does this seem like it's okay, or do you want this worked the long, long, long way? So, because this technique on these works every single time. And it's the same technique. I mean, you just find the base vectors, you list them. You got to make sure you list x, y, z the right way. And then, so with that, how do I get all that knowing, okay, he tells me the flower pot is 40 kilograms. So that's 40 kilograms times 9.81 meters per second. That gives you the number of newtons. Why? Because F is equal to mg. There's your G. There's your M. Or actually, they list it like this. They list it as weight. So I really shouldn't list it that way. So if I do that, okay, where did it go? There it is. 40 times 9.81 just gives you 392.4. So here's the funny thing. I'm going to copy this because I can. And I'll even copy it with the headers on top. And I'm going to do a Control C. I'm going to move down here, sort of put it right there. This time, okay, I already forgot it. What was it, 394? 392.4. So suddenly, there's one thing I actually know. I know what that is. Okay, hang on. 392.4, wasn't it? Okay, I'm already forgetting. Yeah. So, here's what I'm going to do. I'm going to keep everybody else intact. I'm going to basically keep, because I don't know any of these, I'm going to keep those intact, and I'm going to extract out this term. And I'll show you how you do that. So what I'll do this, since I can do this through the magic of copying. I'll tell you what, let me get rid of that little spot. I'll take this out, the copy, I'll drop it right there. And the reason I'm dropping it is because I'm going to do this. Now, okay, here. Get it a little closer to it. Oh. I bent the thing on the pen earlier. It seems to be behaving okay, but sometimes it's acting funny. TAB, TAC, and TAD. Now I got to deal with this. So if I multiply that times that row, what do I get? I get 392.4 times 0, 0, and minus 1. And that's got to equal to 0, 0, 0. So stare at that for a minute and say, hey, wait a minute. If you just had this, you multiply it times that, it's just that. I just extracted it away from the matrix because I know it. And now I can just move it to the other side, and I can do this, copy, put that right there, equal to, okay, 0, 0. Now I'm going to multiply this times that, move it to the right hand side, and get 392.4. And suddenly I got something that I can just put straight into Octave, MATLAB, whatever it is you've got, and inverse that. Now, first thing you can do is you can notice the bottom row. This. So if you extract back out the bottom row, let's just do that real quick. TAD 514. Is this viewable on screen? Yeah. Kind of. Is it okay? 51450 equal to 392.4. I can basically pull that out, and I'll do that one, and then I'm going to do the matrix itself. Divided by 0.5145. And I know there's extra digits. So it says 762.68. Now I can go up here and insert that in here and move it to the other side. And maybe I should do that. Maybe I shouldn't. I don't know. So this was from the lower equation. If I take the second equation out, I'll notice that I have TAB minus 0.68599 times TAD, which in fact is equal to nothing, because there's nothing over there. So I can go ahead and say, well, TAB is equal to that number times 0.68. Let's see, okay. So I can take that upper number, and I'll just copy it that way, times 0.68599. 0.68599. So I get 523.19. And I can go on and do this, or I can just go straight to Octave and list in this matrix. And I usually use the letter K for some reason. And then I always use right hand side for this. So let me try to do that. And what I'll do, I'll sort of list it and then I'll zoom in on it. So let me get it in there and then I'll zoom in on it. Okay. K matrix equals to, did I put the equals? I did not put the equals. Equals to 0, 1, minus 0.5, 1, 4, 5, 0. Next row says 1, 0, minus 0.68, 599, next row, 0, 0.5, 145. Okay, let me zoom in on this. So what I'm doing is so what this, in the syntax of MATLAB or Octave, you put a space or a comma. You can put a comma here as well. So you can leave a space between the numbers or a comma, and it'll list the rows. And then the semicolon says, go to the next thing and list the next row. So there's my next row. And then list the next row. So my right-hand side is pretty simple. Right-hand side is equal to nothing. Oh, next row, nothing, next row. 392.4. Oh, I forgot to put the square bracket to end it. Okay, there's my right-hand side. So now I do the inverse of K times the right-hand side. And gets me 523. Okay, so let me I'll bounce back and forth between these using the shift tab or whatever. So I'm going to list it in this order here to be TAB, TAC, and TAD. And I'm just going to go up here, Alt tab, that's what it is. 523, and I don't know why I'm copying these down. 392, 0.4, and 762.68. Okay, TAB, there's that one, and then this one is that one, and then I did not, I guess I didn't really feel like doing that last one. Did I copy that right? TAC, that's the middle one, yeah. Okay, so let's see how this compares to what he has in the answer at the back of the book. But to do that, I need to know what the problem number is. 343. The second thing, that's the wrong, that's dynamics. Let's see. Okay. 3. Okay, this is the F problem, the fundamentals. And then after that becomes, oh, okay. Wow, I'm confused. Okay. What is going on here? There's only 2? Wait a minute. That doesn't make sense. Oh, these are preliminary problems. Okay. That's the preliminary problems. Never mind. There we go. No, that's the R problems. That's review problems. Okay, where's the regular problem? Oh, there they are. Okay. 3. Oh, geez, I already forgot the number. 43. So, you know, I can't bounce back and forth, but I can do this. Okay. And then I'll head back over here. And then try to find where I put my answers at. And I'll sort of put back of the book answers up there. So so I used the letter T for tension. He used the letter F for force. And maybe I should have done that. So AD, you got that one. AC, got that one. And AB's got that one. So this is a little bit different approach that I do. But what's funny is on these, it simply always works. This one was a little bit different. I did something different in that I basically found all the unit vectors. There's one unit vector. There's another unit vector. These were easy because those two were like, they weren't quite a joke, but they were pretty much, these three, the easiest ones I've ever seen. This one took a little work. I had to find the vector and then find its length and get the answers out of that. And then if you're used to matrices, which you might as well get used to them, because if you get it to the point where you can see and understand what's going on. I know in circuits, I don't know when you've got to take circuits. But circuits is full of matrices like this. The difference in circuits is this might be a voltage or a current, and these might be the resistances. The difference in a circuit, so you might have 20 of these. I mean, that's a big problem to have 20 of those. But here in this course, you're probably only going to have at most. Well, you're only going to have 3 equations here. So, you might have multiple things here. One of them, or 3 of them are going to be unknown because you got 3 equations. So, all right, so let's hit another one. You'll see the same sequence over and over and over. Oh God, that's almost the same exact problem. But he isn't. That one's interesting. Let's do that one. This one's slightly a little bit more. So he says it can't exceed 300. Oh wait, the tension in each cable, in every cable, which there's only 2, can't exceed 300. So what I'm going to do is I'm going to say this thing right here weighs a pound, and we'll multiply it times a scalar in order to get this. But same thing. Right, now this one's slightly different because, and I'll show you why. I've got a tension that's going to head back this way. So I'm going to call it the unit vector. It's going in the direction from A to B. And I got a tension that's heading back this way. Goes in a unit vector from A to C. Now, this one, okay, well, I'll go ahead and do this one. I'll call this B for box. No, there's already a B. P for package. How about that? UAP. Now, this one is interesting because actually I'm going to make an assumption. It turns out if I make this assumption wrong, and maybe I should make it wrong. Did I mess up and not zoom out? Okay, sorry about that. Y'all should tell me. Unless you're watching it online. Are you watching it online? Oh, okay. Yeah, so sorry about that. It may. And unfortunately, I'm like a few seconds behind. So I'll call that P. Now here, I'm going to make this assumption, but I'm going to assume this wrong. I know this strut right here is going to have to supply a force in this direction. Okay, but I'm going to purposely choose the wrong direction. I am going to choose this direction. And I'm going to call it UAD. Now, I'm doing this on purpose. I'm choosing the wrong direction on purpose. And you'll find out all it does is it flips the sign. So I'm going to do the same thing. I'm going to head off. I guess I'll find the easiest ones first, which actually, there's only one easy one. Okay, and that is this, minus K. Okay, so now, oh geez, I've got some work to do on this. You know what I should do? I think I'm going to copy this and then work on it over here so that I don't mess up the original. Okay, so if you zoom out, you'll see I have 2 of them. I have one here. So first thing I'm going to do is I'm going to work on getting this one. So now, unfortunately, I can't follow the sequence, but I mean, I could, but it might be more realistic to find the sequence. It goes from A to B. I'm going to list them in a different sequence now. Let's see. You may laugh at me, and I don't want to make it too confusing. But I am going to do this in a weird way. I'm going to go a vector here. Then I'm going to go a vector this way. Then I'm going to go a vector to here. And then I'm going to go back up this vector. Isn't that weird? So I have two Z components. Is that Z? Yeah, that's the Z. So I'm going to list them. Okay, this one is minus 2.5, and it's in the Z direction. And then I'm just going to list them right under each other. And then I go this one, which is minus 6J. So this vector got to here. So at this point, I'm at D. And then I go to the right, 2, go 2I. And then I go back up 4. Okay, so does that make sense? Okay. This is a little bit different way that I have done in the past, but maybe it's a little bit more instructive this way. You could just make your way from here to here through a bunch of orthogonal vectors. So this one is minus 6J, this one is 2I, and this one is 4K. So if you add all these up, you'll get this. A little bit weird, a little bit strange. I only have two of them that kind of can go together. So all I'll have is a 2I, then I'll have a minus 6J. You'll add 4, take away 2. So that's 1.5, isn't it? Dang. Make sure I'm doing that right. So 4 minus 2.5. So you add 1 to 2.5, you get 3.5. You got another. Okay, so here. Well, why would I write it again? So here I'm going to find the unit vector from A to B as being RAB over the length of RAB. And so, oh, I'm not supposed to do the next question. Oh, no. Yeah, because I got 9 more minutes. You know what? I won't be able to finish this, but I can keep going and then just pick it right back up on Wednesday, WNT. So let me head over to, not to there, to octave. Now let me get the sequencing back. Okay, so there's octave, and there's that. Come on down. So I'm going to try to clear this because there's too much trash in there right now. Clear the screen. RAB is equal to a vector that is 2. I'll put the comma this time. Times 6. And then what I'll do is intermix it. 1.5. And what you notice, it still works with the comma, without it. So it treats that comma and that space the same exact way. However, it does not like it if you do something like this. So it says the vertical dimension mismatch, 1 versus 2 versus 1. So this told it to skip a line, but it was like, hey, you didn't put enough information in there. So you don't want to do that. So there's that. Y'all find UAB is equal to RAB divided by the norm of RAB. Boom. Got a bunch of funny, weird looking numbers there. So I'm going to go ahead and write those down because those will populate a column vector in here. So, oops, I meant to write UAB equals 2, okay? 0.3079. Is that right? No, 769. Just so I can read it tomorrow, I'll do that. Minus 0.92, not tomorrow, but Wednesday. 92308 J and 23077 K. Now, I wish I had written that in not a, I wish I had written it flat like that, but I don't know that I can rotate, but I can copy that, but anyway. So I got one of them. Now, what I can do, and I think I'm going to go ahead and do this. So I know I got 4 of these vectors. I'm going to write it kind of big. I'll have some of the forces in the x equation sitting, equaling 0, sitting right here. Some of the forces in the y equation equals 0, sitting right here. Some of the forces in the z direction equals 0, sitting right here. Now, how do I want to list this? I really don't know. TAB, TAC, TAD, and TAP. And now I'm running into problems. Let's see. Let's do it this way. I'll move this out of the way. Shrink this down. Move that over. Shrink that back up. Move this back up here. And my mistake, there shouldn't be a vector on that. And then what I'll do, okay, hello. That was weird. TAB, TAC, TAD, and TAP. Now, I will say, in mathematics, they don't list this on top. That's usually not listed there. I'm only listing it because the first column is associated with this. The second column is associated with that. Third column is associated there. And the fourth column is associated there. In a math course, they won't list those across the top. But I'm going to keep doing that throughout. Now, here's your 0. Okay, so if you got 0, some of the forces equal 0. Those sit right there. Okay, so now I'm going to start populating as I find the vectors. And since I can't do a good job of looking and seeing, I'm going to move this over and then copy it, and then I'm going to delete it. So here's what I'm going to do. Unfortunately, I wrote it at an angle. I should not have done that. But what I'm going to do, I'm just setting it there as a reference. It's associated with UAV. So now I can copy it. 0.3079. Again, this is associated with the X. This one is associated with the Y. And this one is associated with the Z. So you got to maintain that structure. This is kind of like programming. You have a certain structure here. 308.23077. So I just got to go in and find this one. This one right here, the TAP. Man, that one's pretty simple. 0, 0, minus 1. That one I can go ahead and do. So the next thing I need to do is I need to find this vector. The unit vector here, the unit vector here. Fill it out, and then I can just do the math, and it'll give me the solution. So I got 3 more minutes, and I'm getting hungry. It is That's right, it is 12. And I gotta go teach another class. So I did bring some clappers. So at least I can survive. Okay, so what I'll do is I'll start doing this, and then I'll finish this next time. So what I'll do is I'll go about right here. Okay, now this one, okay, this one was one base vector, okay. Now I'm going to do this other one. So I'm going to lay it out, and then we'll finish it up next time. So what I'll do is I'm going to head down. I'm going to go here. That's minus 2.5K. I'm going to head to here. That's minus 6J. Then I got two choices. I could head here and then head up, or I could head up and then head over. Really doesn't matter. I'm going to head up. I'm going to go up here. This is 5.5K. And then I'm going to head over to I, sorry, because I'm writing out there. Now, I hope I did all that right. So if I'm going to transverse and go from A to C, I'm going to say the only two I combine is these. So I got 2I, that's an I right there, minus 6J, and then 5.5 and 2. What's that? That's 3, right? 3K. Now, you know what? I'm going to do this. Okay, this is the name of the problem. Let's see. Here's what I'll do. I'm going to go in here. Where would it go? Oh, there it is. You can put a little thing here. I'll say, wait a minute. Why is it there? Why can't I put it right here? Okay. I'll say Wednesday. W-N-S-D. Okay, Wednesday. I'll just say that. Did it keep it? Okay, let's see. Yes, it did. So that's where I'll pick up next time. I'll pick up exactly right here.